Everyone, welcome to our second lesson. Today we are going to be looking at square roots, and like addition is to subtraction, roots are to exponents. Essentially, they are opposite operations. And so to solve a square root, we look at the number that is inside the root, and we try to figure out what number squared gives you the number that is inside the root. So for example, if we're looking at the root of 9, we're trying to figure out what number squared gives us this 9. And from our previous lesson on exponents, we know that 3 times 3 will give us 9, and 3 times 3 can be written as 3 squared. Now once you get here, you can simply cancel out the square root and the exponent, and our answer is 3. And perfect squares are squares of whole numbers. So for example, if you were to take the root of 1, the root of 9, the root of 25, all of those would give us a whole number and not a decimal number. And you get through doing square roots a lot faster if you memorize all of the perfect squares up to around 144. But let's take a look at some perfect square root examples. So this is the one that we did earlier, the root of 9. So we're trying to find the number squared that gives us 9. And we know that 3 times 3 will give us 9. And then we cancel out the root and the 2, and we get 3. Same thing for 81. For 81 is equal to 9 squared, 9 times 9. And the root and the exponent cancel out, so we end up with 9. For 4 is equal to 2 squared, and so they cancel, and we end up with 2. 25 is 5 squared, end up with 5. 49 is 7 squared, we end up with 7. And 100 is 10 squared, so we end up with 10. 64 is 8 squared, 8. 36 is 6 squared, we end up with 6. And 1 is always equal to 1 squared, so we just end up with 1. And I did these all rather quickly because I have them memorized, but you guys should try them all again on your own and check if you get the right answers. Now, when we're doing square roots, we have 2 rules that we have to follow. The first one is that the number that is inside your square root cannot be negative. It has to be a positive number. And because it's a positive number, your answer will always be a positive. Another thing to remember is BEDMAS. And this is going to be important for our practice too here. While square roots aren't explicitly in BEDMAS, they fall under exponents. So we would do them after we do brackets, but before we look at division or multiplication. So looking at practice A here, we have root of 16 multiplied by another root of 16. So first we need to solve the square roots before we can multiply them together. So the root of 16 is equal to the root of 4 squared. And so we end up with 4 times 4, which is 16. For B, same thing, we do the roots first before the division. So the root of 144 is equal to the root of 12 squared divided by the root of 9, which is the root of 3 squared. So we end up with 12 divided by 3, which is 4. Same thing here, we start with the roots. The root of 81 is equal to the root of 9 squared minus the root of 100, 10 squared. So we end up with 9 minus 10, which is negative 1. And last but not least, here first we have to solve what's inside the square root before we can take the square root. An important thing to know is that the root of 64 minus 48 is not equal to the root of 64 minus the root of 48. You cannot separate the root if it's if the two numbers are being added or subtracted. So to solve this, we have to first solve what's inside the square root. So 64 minus 48 is 16 minus 2. And now we can take the square root of 16, where 16 is equal to 4 squared. So we get 3 minus 4 minus 2. This is negative 1 minus 2. We end up with negative 3. Now, if your square root is not a perfect square, then what do? Well, then we would break down the number inside the square root into smaller numbers, and maybe one of them will end up being a perfect square that we can then solve. So for 32, for example, 32 is divisible by 2. So 32 is equal to 2 times 16. Now, if this was addition here in the middle, we would not be able to do this, but for multiplication, we can split the square root into the root of 2 times the root of 16. And we know the root of 16 is a perfect square, so we can go ahead and solve that. The root of 16 is the root of 4 squared, and so we end up with root 2 times 4. Now, sadly, root 2 is not a perfect square, so we will just leave that as is, and we end up with 4 times the root of 2. Let's try the root of 72 now. The same idea, it is divisible by 2. So 72 is 2 times 36. And like we did before, we can split it into root 2 times root 36. And 36 is another perfect square. So we can go ahead and solve that. 36 is 6 squared. So we end up with 6 root 2. For root 18, we know that 18 is equal to 2 times 9. And we can split the square root again. And we end up with the root of 9, which is also a perfect square. The root of 9 is equal to 3 squared. So we end up with 3 root 2. And same thing for the root of 8. 8 is equal to 2 times 4. And we know that the root of 4 is a perfect square, so we can go ahead and solve that. The root of 4 is equal to 2 squared. Well, the root of 2 squared. So we end up with 2 root 2. So similarly to what we just did with multiplication, we can do the exact same thing with division. So if we have the root of a fraction, we can split it into the root of the numerator over the root of the denominator. However, the denominator cannot be 0 because we would have an undefined fraction. So let's try an example here. This can be rewritten as the root of 27 over the root of 36. And while 36 is a perfect square, 27 is not, so we will need to break it down. 27 is not divisible by 2, however, it is divisible by 3. 27 is 3 times 9. And then our root of 36 is equal to root of 6 squared. And here at the top, we can break this down even farther. And our root 9 is a perfect square, so we end up with root 3 times the root of 3 squared over 6. And so we end up with 3 root 3 over 6. And this can be even further simplified because it can be written as 3 over 6 times root 3. And 3 over 6 is 1 over 2. And that is our final answer. I suggest you guys try the next two, I believe, on your own to see if you can get them on your own, and then watch the rest of this video and see if you got the right answer. So let's take a look at b over here. We can rewrite this root as root 32 over root 36. Now, root 32 is not a perfect square, but 32 is divisible by 2. So 32 is 2 times 16. And our root 36 is a perfect square, like the previous question. 36 is 6 squared. And so here we can split, let me erase this. Here we can split the root into root 2 times root 16 over 6. And root 16 is a perfect square. It's 4 squared. So we end up with 4 root 2 over 6. And yet again, 4 over 6 can be simplified. Both are divisible. Both the numerator and the denominator are divisible by 2. So we end up with 2 over 3 times root 2. And one more question. Hopefully, the more practice you guys do, it'll get easier. So let's do this one. The same idea. It can be written as root 8 over root 25. And root 8 is not a perfect square, but it is divisible by 2. 8 is divisible by 2, so we can rewrite 8 as 2 times 4. And then 25, the root of 25 is a perfect square, so we can write that as 5 squared. And we can rewrite our numerator. And here this will cancel, and we end up with 5. And root 4 is a perfect square. 4 is 2 squared. So we end up with 2 over 5 times root 2. Now, other kinds of roots also exist, not only square roots. There are cube roots, fifth roots, and lots of other roots. Basically, you look at this little number here on top of the root. And usually if there is no number there, it is a square root. Not usually, it is always a square root if there is no number. If it is just written like this, then it is a square root. And you do not need that little 2. But if it's a cube root, you need to make sure that you write a 3 there. Now, when we solved a square root, we looked at the number inside of the root and found the number squared that gives us that number that is inside the root. And it's the same idea for a cube root, but now we are looking for the number cubed that gives us the number inside of the root. And if it was a fifth root, we'd be looking at the number to the power of 5 that gives us that number inside of the root. Let's do some examples. So to find the cube root of 27 here, we are trying to find the number cubed that equals 27. So in this case, it would be 3 times 3 times 3 that gives us 27. And this is 3 cubed. And now we can cancel those and we end up with 3. Same idea for the cube root of 64. For 64 is equal to 4 cubed. And so the cube root of 64 is 4. For 125 is equal to 5 cubed. And so the cube root of 125 is 5. And the cube root of 8 is equal to 2 to the power of 3. So the cube root of 8 is 2. Now, remember earlier when I mentioned that in BEDMAS, the E also accounts for roots. Now, why is that the case? Because a square root, or any root, can be written as an exponent, just like that. So if you had the square root of 2, and you wanted to write it to the power of an exponent, you would take 2 to the 1/2 because this is a square root. Remember, if it doesn't have a little 2 there or any little number there, you know that it is always a square root. So what if we had 8 to the power of 4 over 3? How would we write that? It's not exactly a cube root or a square root. Well, it is a cube root, but what is this number here on the top? Well, because we have a 3 here as the denominator of the exponent, we know that it is a cube root. So it is the cube root of 8. And this 4 here, it's just the exponent. So we would put the whole cube root to the power of 4. And then you can solve this cube root and take the exponent of it to get your answer, which is shown here. So let's do some more examples like that one, and hopefully it will make more sense. So here we have 4 to the power of 3 over 2. So the first thing is we look at the denominator of the exponent, and since it's a 2, we know that it is the square root of 2. And then the 3 tells us the exponent that it is put to. And to solve this further, we know that the square root of 4 is a perfect square, which is 2 squared to the power of 3. So we end up with 2 to the power of 3, which is 8. And see, here is the same idea. We're looking at 27 to the power of 2/3. So the denominator of the exponent is a 3, so we know that we're taking the cube root of 27 and that it's to the power of 2. And so to find the cube root, we find the number cubed that gives us 27. And in this case, it is 3 cubed. So we end up with 3 squared, which is 9. For B, we're looking at 49 to the power of 1/2. And we look at the denominator here, which is a 2, so we know that we're taking the square root of 49, and the exponent is just a 1, so it doesn't really matter. So to take the square root of 49, we know that 49 is a perfect square, and it is 7 squared, so we end up with 7. Last but not least, we have 8 to the power of 5 over 3. So we look at the denominator, which is a 3, so we know we're taking the cube root of 8, and it's to the power of 5. And so the cube root of 8, what number cubed gives us 8? 2 cubed. And so we end up with 2 to the power of 5, which is 32. So now we're going to do some practice. It's all the same idea, but more practice you guys get in, the better it is, and the easier roots will become for you. So here we are looking at the root of 3 times 3 to the power of 1/2. And as we mentioned before with BEDMAS, we have to do the exponents and the roots before we touch division and multiplication. So we have root 3 times 3 to the power of 1/2, which is the square root of 3 because we look at the denominator. And we can do the root of 3 times 3. You cannot do this if you are adding two roots together or subtracting, only if you're multiplying or dividing. And so we end up with the root of 9, which is a perfect square. As you can see here, it's the root of 3 squared, which gives us 3. Now, this is one way to do it where you convert the exponents into roots, or you can convert the roots into exponents, which we're going to try here. So here we have 2 to the power of 3 over 2 times the root of 2. Now, how do we write the root of 2 as an exponent? Well, we have 2 as the base because it's the thing inside the root, and since this is a square root, it would go to the power of 1 over 2. And to bring these two together, when you're multiplying two numbers that have the same base, so in this case 2, you can just add the exponents together. So we would end up with 2 to the power of 4 over 2, which is 2 to the power of 1/2, or root 2. I'm so sorry. 4 over 2 is not 1/2. It's 2. Oof. Yes, so 2 to the power of 4 over 2 is 2 to the power of 2, which is 4. My apologies. Let's do some more examples. So here we can try to convert it all into exponents. So we have the root of 5, which can be written as 5 to the power of 1/2 because it's a square root, multiplied by 5 over 1/2 to the power of 1/2. And since these are both the same base, we can add the exponents, and we will get 5 to the power of 2 over 2, which is 5 to the power of 1, which is 5. Similar idea here. So this term here looks a little bit different than we usually see. So this is equal to the root of 2 to the power of 3 times 2 to the 3, 2. So how do we put this into an exponent? Well, we have the base of 2, and we know that it's a square root, so our denominator in the exponent is a 2, and we are putting the entire thing to an exponent of 3, so that is our numerator, times 2, 3 over 2. And since these are the same bases, we can add our exponents to get 2 to the 6 over 2, which is the same as 2 to the power of 3, which is 8. And we can take a look at C. Root 7 is equal to 7 to the power of 1/2 because it is the square root, times 7 to 3/2. And since it's the same base, we can add our exponents. 4 over 2, and this is 7 squared, which is 49. And let's take a look at G over here. So we have 2 to the 3/2 divided by root 2. So that is 2 to the half because it is a square root. And when we are dividing two numbers that have exponents and the bases are the same, in this case the base is 2, we can subtract the exponents. As opposed to when we multiply, like here, we added these exponents. But here, because we are dividing, we can do 3 over 2 minus 1 over 2. So we end up with 2 to the power of 2 over 2, which is 2 to the 1, which is just 2. And let's take a look at D over here. We have root 2, which can be written as 2 to the 1/2 divided by 2 to the power of 1/2. And because we're dividing and these are the same bases, we can do 1 over 2 minus 1 over 2. So we end up with 2 to the 0. And if you remember our previous lesson, anything to the power of 0, anything at all, is always equal to 1. And lastly, we have 2 to the power of 3 over 2 times 2 to the 1/2. And now we're multiplying, so we will add our exponents. And we end up with 2 to the power of 4 over 2, which is 4. So now we're going to do some challenge questions. These might be similar to ones you see on the contest, like the ones that would be at the very end, the harder ones. So let's take a look at the first one here. Please pause the video and try it yourself first. There are 2 here if you want to get started on them before watching the video. So for the first question, we are looking for x in this equation. And the x is right here. It's the exponent to the 4. So where do we even start for this question? The way I would look at it is that we want to try to get this term here. We want to try to get it to the base of 4. Because if we get it to the base of 4, the exponent here, whatever number that is going to be our x. So in order to simplify this, we can first get it out of its root. So because we know that it's a square root, it is to the power of 1/2, like we just did earlier. And when we're dealing with a situation like this, we can multiply these exponents together. And so we end up with 16 to the power of 8. Now we have to get this 16 into a base of 4. So how do we do that? Well, we want to find the number squared or cubed or whatever that gives us 16. And in this case, it would be 4 squared. And here we can multiply these exponents. So 2 times 8 is 16, and 4 to the power of 16 is equal to 4x. And since these bases are the same, they're both 4, we know that x is equal to 16. And that's how we would solve that first question. And for the second challenge question, it looks rather intimidating, all of the square roots, but don't worry, we will go through this one slowly. So the first thing that might make this a little less intimidating is to break down this 256 into its factors and maybe write it as an exponent. So there are 2, 3, 4 roots, and 256 is divisible by 2. 256 is equal to 2 times 128. And now we can break down 128. 128 is equal to 2 times 64. And now we can break down 64. And 64 is 2 times 32. And now we can break down the 32. And 32 is 2 times 16. Now we can break down the 16. And the 16 is 2 times 8. And we can break down the 8. 8 is 2 times 4. And 4 is 2 times 2, so I'm going to write it like that. Now we can write this long string of 2's into an exponent. So we have 1, 2, 3, 4, 5, 6, 7, 8 2's. So we can rewrite this as 2 to the 8. And now we can take a look at getting rid of all of these square roots. So we start with the very first square root here. We have these ones. And we know that when you have a square root is equal to the exponent of 1/2. So we would get this. And we can simplify that to 2 to the 4, because 8 divided by 2 is 4. Now we can take a look at this square root. So we would write it again as to the power of 1/2. And 2 to the power of 4 divided by 2 is 2. So we end up with 2 squared. And now we get rid of this square root. And I've run out of space. Let me erase this. And 2 squared times the exponent of 1 over 2 gives us the root of 2. And this is as simple as this very intimidating term can get. And so we've come to the end of all the questions, and if you guys have any kind of questions or comments or concerns, please post them on the Google Classroom and we will be sure to answer them. Thank you so much for watching, and I hope you guys learned something. Thank you, and have a nice week.